That command lets you look at the first 10 things. How do you make it actually look at 10? There's like 2 arrow ampersand 1.
Right, you say, so then like, you would say head, and then dash.
Oh, there's a dash?
Dash N maybe, and then 10.
Well, actually, isn't the default 10?
You can type man, M-A-N, space.
Is the default 10?
Head. And then
This is only getting 2 errors. Neither one of them are.
but the 2 errors might be, that still might be 10 lines.
Oh.
It's not number of errors, it's number of lines.
So D20, type in dash N space 20.
You type that after head, right? You type dash N and then space 20 for 20 lines.
Yeah, it's either dash N, I don't remember exactly.
Oh, you might have, yeah, you're right.
Alright, you guys ready? You've been ready. You're like,
Are you ready?
maybe you're beyond ready, right? You like got ready, you got psyched up for a lecture.
Oh, yeah.
And now, like 20 minutes later, you're like ready to pass out.
I mean, you kind of ruined it. My other class canceled for today.
Oh, did it? Oh.
You showed up.
You were hoping, right? Hey, if you come out to campus, I would rather have class than not.
Yeah, I know.
That's my own personal thing. It's like,
No, that's the worst
I'm
part.
still at home and class is canceled, great. But if I'm already on my way,
We've been out here for a while.
my mindset's already got to it. So we're working on linked lists, right? And linked lists are made up of what?
Lists.
Nodes?
Lists? No, what's inside the list?
Nodes.
Nodes, right? And so for our labs, we're calling that SL node.
Yes.
Are you good with that? So we have SL node, and inside of SL node, right? What is it made up of? It's made up of an int, right? Contents,
Mm-hmm.
right? And then what else? Good, a node pointer. So a pointer that can point to a node of type, right? SL node
Star.
star, and then we call it next node. Why do we call it next node?
It just points to the next one.
Because it's supposed to point to the next node, right? And then by default, right, we created some constructors for this node, and by default, right, contents get set to 0, right? And this gets set to what? Does that make sense? Are we good so far? Now, because these are private member variables, we don't have access to them, correct? Direct access to them. So what do we do, right, for private variables when we don't have direct access? What do we write?
Accessors.
Accessors and mutators, right? And so, right, if we think of this as the pointer coming out, right, we can get its value with next node paren, right? And we can set its value with set next node, right? And that one takes something in the parens, right? A pointer to some other node. Are we kind of good with that so far? Right? And then contents, right, is some number, right? And it is basically what? Set contents, right? Some integer goes in there, right? And then contents. Right? Technically, what goes in here is an SL node star. Does that make sense? Now, each of these nodes we create dynamically, right? That's why a linked list is a dynamic data structure, right? Which means that this node gets created dynamically with the keyword what? New. And so it has some, right, pointer of type SL node star, right, that points to it. Does that make sense?
Mm-hmm.
Right, it has some pointer of type SL node star, which happens to be the same type that's inside of my node, but this is internal private, this is just some variable. Right? And what I'm trying to get at is that if I want to change this stuff, right, I have to use the pointer. So I have to say what? Node, right, arrow something. Right? Node arrow the accessor, contents, next node, node arrow the what? The mutator, set contents, set next. Does that make sense? Am I kind of good with that idea? Questions there? So that's working with the node, and that's important because, right, the list class, right, takes the nodes and it's the thing that organizes them into what we consider a linked list. And so my linked list, let's change colors. My linked list is made up of a bunch of nodes, right? Node 1 points to node 2, right? Points to node 3, right? And then points to null eventually. Right? They all have content. 1, 5, 2, right? In our example, they're all of type what?
That's all nodes are.
Well, technically, they're just SL node.
Oh, other objects.
Right. Because they're objects, right? Which is why, and they're dynamic, which is why we have pointers to them. Right? And so what do I need in my list? I need a what? What do I need at the beginning?
A head.
A head pointer, right? So I need head, right? That points to the beginning. Now head is of type SL node star, right? It is not a node, it's the pointer that points to the beginning of my list, right? When there's content, it points to the first node. When there's not content, it points to what? Null. Does that make sense? All right. Today, we're going to introduce this idea, tail underscore. And tail underscore does not point to the end of the list, because the end of the list is always null, right? It points to the last node in the list. We're going to talk about why it's beneficial to have a tail node. Does that make sense a little bit? Any other questions there? Okay, a couple housekeeping things. Our second midterm is a week from today. So next Wednesday is a midterm. It's going to look a lot like the first midterm, although lucky for you, a lot less multiple choice because no one did get on it. Let's just be honest. All that part was tested in the first midterm was can you speak programmer, and y'all didn't do so well with it. But I think you can speak programmer now, so that's good. So there'll be some code portion, which will be more of like, can you create a dynamic array and do something with it? Since that's what our data assignment was on, right? Remember, the test is never going to be as hard as an assignment because you only have an hour and a half to do it, or 2 hours and 15 minutes to do it, as opposed to 4 weeks. Does that make sense? So don't freak out about how hard it's going to be, but you should know how to create an array dynamically. You should know how to delete an array dynamically. I would guess that it's probably not a dynamic array of dynamic things. That's probably a little too much for what we need. If you do, trying to think if it's on there or not. Lab 16, which is the one we skipped, is probably the closest to what this is going to be. Does that make sense a little bit? All right. And then your new assignment's up because we just keep piling on, right? If you anyone read the new assignment?
Nope. All the labs are there as well.
Yeah, right. All the labs are there, the assignments are there. Good news about the assignment, it's making a linked list. What are we doing? Last lab, this lab, next lab, what are we making? Linked list. So you'll have a pretty good foundation for what you need. And in fact, you can make the node class right now, right? You don't need the rest of this in order to make the node class. You can write one of the 2 classes of your assignment today. You can have it done. Okay, let's do it in 2 weeks. And in those 2 weeks, you also have a what? A midterm, right? Next Wednesday. So the sooner you get on it, the better you can be. We have 5 weeks left in the semester, so things are slowly coming to an end. Hopefully good, right? Maybe? Questions?
I guess this is a general school question, but with the days off, have they figured out what they're doing with Thanksgiving break? Are we still going to?
Yeah, Thanksgiving break's still normal, which means Monday, Tuesday, Wednesday. And our final will be, well, no, we're a week before that, so that's actually the midterm. So, but we'll do normal class that Wednesday. And then the other thing is that finals week has been converted to just a regular week, which means that we'll meet twice as opposed to once, which allows me to get in one more lecture, which I'm excited about. Christmas starts later for the rest of y'all. Yeah, you can have that 3x5 handwritten note card again, right? That's 3 meters by 5 meters.
Meters.
So if you just make one, and we'll just paste it on the wall, and everyone will come up to it.
So you said 3 meters by 5
Right,
meters.
exactly.
So I can have one like.
But the pencil's like one of those like big, have you seen like the big pencils too? So that's what you have to write with as well. So they all kind of even out.
What should we expect on like the
Yeah, so classes, pointers, sorting algorithms. So maybe I'll give you the sorting algorithm and I'll say, can you show me each step? So can you show me what swaps and that kind of stuff. Linked lists will be on there, but they will not be the code portion. Code portion is an array, dynamic array of stuff. But I will have you write a little bit of code with linked lists, but it'll be on the table portion. So can you make a node, right, point to another node? Basically, do you know when to dereference and when to not dereference? When to use the arrow operator or not? No, I don't think there'll be a study guide. This is my study guide. Look at everything from the last midterm to now, and that's what will be on this midterm.
Oh.
Which is pointers, sorting algorithms, and linked lists. That's everything that we've done since the last one. So we did classes, and then we ended midterm 1. We came back. I guess we did overloaded operators, but that's just me being able to do that. Overloaded operators, and then we did pointers, and then we did sorting algorithms, and now we have.
Can you tell us anything about what the coding part in the midterm will be like?
I can. I've already said it 3 times.
Oh, you did?
So.
Sorry.
So maybe ask someone else. I don't want to say it again. Other questions?
Look at lab 16.
What?
Look at lab 16.
Yeah, look at lab 16. There you go. And if it's not, someone remind me. If I never put it up there because I never assigned it, then let me know and I'll put it up. Okay.
Okay.
All right. I'll put it up.
I assumed you were doing that on purpose.
That's the
Just
challenge.
study Lab 16. It's not that.
Yeah, study that. I like it when because then I get to know who studies when, and when they email me at 1 in the morning, the day of. There's no 16. I'm like, you just started studying now? Really?
Hey, I'm just giving them the props that they're at least trying.
Yeah, right, exactly. It's not at 6 in the morning.
It's not half hour before class. You didn't put lab 16 up.
Yeah, that's true. So today we're doing tail, and all we're gonna do with tail is add to the tail, remove from the tail. So that's the only algorithm we're gonna work on today. But once you introduce tail, it modifies your add to head algorithm and your remove from head algorithm in some instances. So we're gonna talk about how you could modify, right, what you did in your previous lab before today's lab. Good? So the beauty of linked lists is they grow dynamically, right? They don't have to resize, all that fun stuff. Kind of the detriment is that you only have a head pointer. So if you want to get anywhere, you always have to start where? At the head. Now, if you are creating something that deals with the end of your list a lot, right? So a lot of times we talk about adding to the front of something, right? But sometimes we want to add to the end of something. And so if you're going to add to the end a lot, it might be nice to have a pointer dedicated to the end, so you don't have to start at the beginning and go in nodes down your list. Does that make sense? So instead of going in nodes down, you have a link to the end, and you just go straight there, right? Constant time. And constant time we know is better than linear. Good so far? So we can do that, but we want to make sure that we introduce this pointer, because if I don't, I can start at the head, and can I make it to the end? Yeah, right, and you had to do that in your toString, right, because you did not put a comma on the last node, right, it's comma separated, but no comma at the end, so you had to know, hey, I'm at the end, right, don't add a comma, right, so you can get to the end by starting at the beginning, but we don't want to take that time to get to the end, so I want to set up an algorithm in a way that I can just get directly there. That being said, if you seldom access tail, meaning everything's done at the beginning, add things to the front, remove things from the front, add things, remove things, but everything's happening at the beginning, I don't need a tail pointer, right? Because I'm not getting any benefit to it. But if I am accessing a lot at the end, then that's where the tail pointer comes in. So tail always points to the last node in the linked list, whereas head always points to the first node in the linked list. Or, if there is no node, head and tail both point to where? Null, right? That should make sense. If there's no nodes in the list, head and tail point to null. Now, this does make our add to head, remove from head clear, right? Have to deal with the tail pointer because we have to bring the tail pointer into my list, right? If I remove everything from the list, I need to set tail to null, right? So there's a little bit that I have to do with the tail pointer, right? And the algorithms that we've already written, but we'll go through all that and you'll be good to go. Right? Now, there are three main cases. Remember last time I was talking about two main cases, right? The list is empty, the list is not empty, right? When we're talking about tail, there's really three main cases of tail, right? One is the list is empty, and so tail points to where?
No.
Null, okay? The next one is, right, there's one node in the list, right? So if your list is of size 1, where does tail point to?
Where head points to?
To what?
Where head points to?
The same place head points to, right? That's how we're going to define it. When there's one node in the list, tail and head are the same, right? It's like your parents, if you're an only child, you're your parents' favorite child and what? Least favorite child, right? You're both. Right? They let you know which one you are on certain days, right? And then, right, if the list is greater than size 1, then tail points to the last node in the list, right? But if I add to the head, I don't have to mess with tail because it's right farther down the list. Does that make sense? If I add a node to the front here, head's going to all get updated, right? Point the new node to what head is pointing to, point head to the new node. Do I have to mess with tail? No, right? But in the case of the list of size 1, right, the first node in the list, both head and tail have to point to that same node. Agreed? So we have to make sure that that happens. The nice thing is, adding to the head and adding to the tail when the list is of size 1 is the same algorithm. Agreed? So I can leverage my add to head algorithm even if I'm adding to. Okay. So we're going to talk about that. Oh, there's the easy one, right? This happens where? In your
Constructor?
constructor. Good. This happens in your constructor, right? When your list object is created, right? Before we set head to null, and now we're also going to set what? Tail to null, right? And then we also have size, and we would set size to what?
0.
To 0. But we already did that, right? In lab 17, 18, lab 18, I think. Maybe today's 18. I get my days messed up. Right? If you have one node, that node points to null, agreed? But head points to it because it's the first node, but tail points to it because it's the last node. Good? And then, right, there's what I had on the board, but just prettier. Right? Head, which is of type SL node star, points to the first node. Tail, which is also of type SL node star, points to John. Right? Tail points to a node that points to what? Null, right? Tail always points to a node that points to null because it's the last node in the list. Unless the list is empty and then tail points just to null, not to a node that points to. Anyone keep track of how many times I say points to that? It's going to be fun. All right, so tail points to null, right, initially. And we'll go with that at creation of my list, tail points to null, right? After we add the first node to the list, tail points to what?
The new one?
To the new one, which is the same place that
Head points
to, right? So head and tail, right, we saw in the picture, point to the same one. So we add a second node to the head, the beginning of the list. Where does tail point to?
Still pointing to the last one, right?
Still pointing to the last one, right? And if I keep doing that, tail still points to what? The last one. So adding to the head does not mess with tail except when what? When size equals 1. So when you go from list size 0 to list size 1. So we need an if statement to say, hey, if, right, we're going from that condition, right, let's introduce tail into my head algorithm, okay? Now you could use size, but it's always better to check for your pointers because the pointers are what crash your program, right? So if head is null and you're in add to head, if head is null, then you have nothing in there currently, and so that's your first algorithm. Does that make sense? So if head is null, then we're going to do something like that. So let's look at this. If the list is empty, right, this is where we need to introduce the tail pointer. Right? So we want to create Darla, and remember Darla has a pointer pointed to it, right? I always call that new node or NN. So Darla has a new node pointer pointing to her, right? This is the node I want to what? Add to the list, right? This is the node you're creating. You need to call new in your add to head algorithm to create this, right? And so we're going to point tail to the new node, right? If the list is empty, and how do I know if the list is empty?
When head is null.
When head is null. So you can create your new node, and then you can check if head equals null, tail equals what?
No. Or the new.
The new node, right? Tail equals the new node. And then we run the original algorithm. And remember what the original algorithm is? Point the new node to what head is pointing to. And point head to that
New node.
new node.
Uh-huh.
It looks so ugly when you, right? When you don't set it up all nicely. But head points to the first node in the list. Good. Tail points to the last node in the list. And that last node in the list points to where?
No.
No. Is that correct?
Yep.
Everything's good? And all we had to do in my add to head, notice I'm in the algorithm we've already written. In that algorithm, I just need to say, right, if head equals null, tail equals the new node. Right? If head is null, tail equals that new node. Now when it's not empty, right, so we check if the list is empty. Is it empty?
No.
No, head equals null is false, so I don't say tail equals head, agreed? And so then I just run the new algorithm, or the original algorithm, right? So what? Point the new node to what head is pointing to, and point what?
Head to the new node.
Head to the new node. And what do we notice about tail?
It doesn't move.
Doesn't move. Should it move?
Nope.
No, shouldn't move at all. It's good.
We're just changing everything in between head and tail.
Right, exactly. So only time we have to deal with tail in the head algorithm is when, right, the list was empty. It's the first node. Make sense? It's kind of mean that someone moved the clock behind my head. I'm like, I know I'm looking at the clock over here. Now you can just watch the time tick off. That's where I forgot. It is rough, isn't it? But I'm definitely not tall enough to put it back. Removing from the head, right, we need to do a small update again for this one, because when you remove the last node in the list, head's going to point to where? What do you think? When I get rid of the last node in the list, so there is nothing in the list anymore, head should point to where?
No.
Null, which means that tail should also point to where? Null, because I deleted the node that tail was pointing to. Right? When the list is empty, the same algorithm, you don't do anything. When there's more than one node, same algorithm. Delete it, update the links. Right? When you only have one node, we'll talk about how we can write an if statement to deal with that condition. When you only have one node, that's when you have to also update tail. So when the list is empty, do we do anything? No. And remember, you have an if statement, right? If head equals null, right? We don't do anything. Really, it should say if head doesn't equal null, and inside that if statement is where we'll run a deletion algorithm if we need to delete. Right? If there's greater than one node, right? We'll go with this. There's greater than one node. Remove from head is going to get rid of who? Darla, right? And remember the algorithm? What do I need?
A temp, right?
Temp, right? So create a temp pointer, point it to, right, the head node, right? Then point head to the next node. So point head equals head next node. Remember that? And then what? Delete temp. And obviously decrement size. What happens to temp?
Disappears.
It goes away, right? Function ends, it goes away. So that worked. Did tail move?
Nope.
No, not at all. But what? When head and tail, what do you notice about head and tail?
They're both pointing to the same spot.
They both point to the same spot. So when head equals tail, you know that what? There's only one. Right? When head equals tail, you know there's only one. Only because we already did a check for null. Because technically, when there's nothing in the list, head and tail also point to the same place, which is null. Remember, we're inside of an if statement that says if head doesn't equal null. So another way of doing it is that after you delete, if head is pointing to null, right? So when we get rid of Darla, head should point to null. Everyone agree? So after you delete, just check head. If head is null, then what should you do with tail? Tail equals null. Good. So same algorithm. Temp points to what the head is pointing to. Head points to the next node, which in this case actually isn't a node, it's null. Right? Delete temp. Okay. Now this is crucial. Why are we updating the algorithm? Because if I didn't, where is tail pointing to?
Nothing.
Nowhere, right? Not null, garbage, right? Which means that if now I called like insert tail or remove tail, am I gonna have problems? Yes. Right? Because I haven't updated that last link. But at this point in my deletion algorithm for head, I just say if head equals null, does it equal null? Yeah. So what do I say? Tail equals null. You can even say tail equals head, right? Either of those will work just fine. But the key is we want tail to point to null. Now the list is what?
Empty.
Empty. Which means all my algorithms that work on an empty list are going to work. Because head and tail are both null. What was the tip?
It's gone.
Goes away. Right, and we're good. Does that make sense? So far, all we've done is updated the two algorithms that we wrote with our slides last class, right? Add to head, we need to introduce tail to my list. Remove from head, I need to, right, set tail to null when we remove everything from the list. Does that make sense? Are we good there? Right? Clearing is really easy. Right? It's the same algorithm, but then at the very end of the algorithm, you just need to make sure you say what? Tail equals null. Right? That one should be easy to modify. Right? At the end, right, tail should point to null. And we know that size should be 0. Right? Just as a reminder, right, clearing says, right, create an iterator, move head forward, right? Delete the iterator, catch it up. Remember this? Right? If I wrote the slide, I'm going to show you all the animations, right? Right? Iterator's not null, move head forward, delete the iterator, right? It catch the iterator up, right? Then iterator's not null, move the iterator or head forward, delete the iterator, right? Move the iterator forward. This time the iterator is null, so my loop ends. After my loop ends, what do I need to do?
Tail needs to be null.
Tail equals null. And there we go. Just like that. It's like magic. Oh, except you have to write it. That's easy. So clearing is easy, right? Just after your loop, tail equals what? Null. All right, you ready for the two new algorithms? So we're going to have two algorithms, add to head and remove head. Just like we have remove tail. So we have add head, remove head, and now we're going to add tail and remove tail. So those are the two new algorithms. We'll talk about what happens. Okay, so adding to the tail, there's really two conditions, right? Same two conditions that we had for adding to the head. Either the list is what? Empty or it's not. Okay, remember with add to head, it was the same algorithm. It didn't matter. Okay, with tail, it does matter. So let's see what we need to do. So if the list is empty and you're adding a node to the end, what is that the same as? Same as add head. If the list is empty and someone calls add tail, you call a what? Add head. Okay? That has two benefits. One, you don't have to write anything. Two, add head deals with introducing the tail pointer into your list, right? We did a bunch of slides that said, right, if the list is empty and we add one, right, let's introduce tail into the list. Well, I don't need to rewrite that logic, right? The beauty of calling other functions is that I can, right, offload the work to a function that way. So if, right, head is null or if tail is null, it doesn't really matter which of those two checks you do, but in add tail. If head equals null, then just call add head. And pass in the contents that you want it to be. Does that make sense? So that should be pretty easy. All right. If the list is not empty, that's where we need to start figuring out what a tail algorithm is going to look like. It's pretty easy. Point the tail node. So add tail says we're adding a node at the very end of the list. So I want to point the tail node, which is the current end of my list. Everyone good with this? This is the tail node. Now if I have some new node, I want to point the tail node to the new node, basically the new tail, if you want to think of it that way. And then what else should I do? Update tail, point tail to the left.
The new node.
To the new node. Okay. Please look. These look almost exactly the same, but they mean two totally different things. Point the tail what?
Node.
No, the tail node is what tail is pointing to, right? So that is a set next node, right? Point the tail node to the new node. Point the tail node to the new node. And then point the what? Tail to the new node. So what you'll notice is the second to last node and tail are now pointing to the same place because they both point to the new node. One is the pointer inside the last node, and one is the tail pointer. When you see tail node, that's when you use set next node. When you see just tail, that's where you use the assignment operator, right? Because it's not a node, it's just, right, a pointer. Does that make sense a little bit? So they look almost the same, but they, right, the way you write it is slightly different.
You still need to put.
What?
Still need to point your last node to null, right? Or no.
Right, but yes, but by default, yeah.
Yeah, your default instructor.
By default, it's always pointing to null, so we're actually good there. No, null exists everywhere, right? There's not one null that everything points to. One null for everything null, right? And then, right, increment the size of your list. Please don't increment the size of your list outside of your if statement, because remember, if the list is empty, you call the add head function. What is the add function going to do?
Increment size.
It's going to increment the size of your list. If this is not right and the list is not empty logic, then you'll end up incrementing the size of your list twice. All right, so just be careful. All right. So adding to the tail, if it's an empty, we call the add to head function. To recap, create the new node. If head is null, tail equals the
New node.
new node. Right? Then point what? The new node to what head is pointing to, which is still just one. And then point head to what?
New node.
The new node. Right? That's add to head. Now, if we already have a list with a bunch of things, right? We create my new node, and then we say point the tail node to the new node. The tail node is John, so John needs to point to the new node, which is what? Darling. And then point tail to the new node, so tail points to Darling. And we increment size, right? Does that work? Does that make sense? Head still points to the first node, we're all good. That node points to Jane, Jane points to John, John points to Darla. Darla is the last node, which is why tail points to her, and the last node always points to. So we're good there, yeah? All right. By introducing a tail pointer, it makes add to tail a lot more efficient, right? We go from linear time, having to start at head and searching for the last node, linear time, to constant time. I have a pointer to the end, go directly there, and then just update some there. Make sense? So adding a tail pointer makes that more efficient. It does not, unfortunately, make removing from the tail more efficient, and we'll see why. 3 cases for removing from the tail. The list is empty, so we don't remove. There's nothing to remove. The list has one node. And so remove tail is the exact same as what? Remove head, which you should use because remove head deals with updating your tail pointer, right? Or you have more than one node, and so we need to come up with a new algorithm to do that. Let's do that. So if head is null, don't do anything. If tail and head are equal to each other, right, call remove from head, right? Else, right, we're going to work with the third condition. Easy peasy. One node, right? Create a temporary pointer to the head, point head to the next node, delete the temporary pointer. If head equals null, tail equals null. And tip goes. And we decrement size. That's something. All right, you ready for the wrong way?
Yes.
Let's delete the tail. You ready? Right? Hey, I have a pointer to the end. That's what I want to get rid of. Let's delete John. Work for you? Works for me. Right?
Oh.
It works. Did I get rid of the tail now?
Yeah.
Yes. What else do I need to do though? Update my arrows because tail, the last node, pointer to the last node needs to point to who now?
Jane.
Jane. And Jane needs to point to where?
No.
No, but how? I don't have any way to get to Jane except through what? Through head. Okay. And really, since Jane points to garbage, I don't have a good way of getting to her. Does that make sense? Right? So, unfortunately, while tail, right, makes my add to tail more efficient, I'm going to have to start at head to get to the end. Because I just need some more arrows. Because you guys love arrows so much, right? I need more arrows, that way I don't accidentally, right, leave some things dangling. So we need to traverse, right, which means start at the beginning and go through your list. So you stop at the second to last node. Remember, the last node points to where? Null.
To be size -1.
So, right, but my loop, I don't like to loop size -1 because I want to go through my arrows to make sure I have everything set up correctly. So how do I know I'm at the second to last? What? So it stops one before tail, right? So before we looped, right, until like we were at null. Now we need to loop until we're at tail.
Oh.
Okay. So we'll look at this. So create an iterator starting at the beginning, right? You loop until the iterator's next node is tail. We want to stop one before. So while, right, iterator's next node doesn't equal tail, how we loop, right? And once you find it, right, then we're going to do some things. And this works because we already took care of the condition where the list is empty, where there is no next node, right? And where it's of size 1, where there is no second to last node, right? So guaranteed there's at least 2 nodes when I write this loop. So if I loop and I basically have an iterator to here, right? Notice my loop will end and the iterator will be pointing to the second to last node, right? Now I have enough arrows to do some deletion, right? Because if I delete the tail, what goes away? 8 goes away, everyone good with that? But can I get to the new tail? Yeah, because I have an iterator pointing to it. So then I can just say tail equals what? Iterator. I'm just going to ignore whatever that was. And then what else? One more thing.
The node needs to point to null.
Right, so tails set next node should equal what?
Oh.
No. And I say equal, but for us it's not equal because it's a function, right? We'd have to say tail arrow set next node.
Yep.
And then the parens would say what?
No. And the iterator disappears.
And then the iterator disappears. Good. Goodbye, iterator.
Seems a little bit more complicated.
It is a little bit more complicated. And you'll notice that it takes linear time because I have to search through the whole list to get there. So let's do this. Create the iterator, point it to what head is pointing to. So SL node star iterator equals head. It's the same thing that you did in your deletion, your clear algorithm, and in your two-string algorithm. Right? Basically, it's the same loop, the same pointer, all that kind of stuff. All right, and then we loop. While iterator's next node doesn't equal tail, right? While iterator arrow next node, right, doesn't equal, not equal tail. Does that make sense? What that loop's supposed to look like? I try to say it a lot because then when you go to write it, maybe you'll hear my voice, which is a little scary. Right? But you'll hear my voice saying this kind of stuff. Because the slides don't have the code, right? They just have basically the pseudocode. Okay, so each iteration, we move the iterator down. How do we move an iterator down the list?
Set next node.
Yeah, iterator equal, but it's set next node. Okay, this is great. I'm glad you said that. Set next node deals with these arrows. Agreed? I don't want to change these arrows. I want to change iterator's arrow.
Oh, so I meant set it to next.
Yeah, set it to the next node, right? Iterator equals iterator arrow next node. Iterator equals iterator's next node arrow. Right?
Huh.
And then we loop again. Does iterator's next node equal tail? Does iterator's next node arrow equal tail's arrow?
Yeah.
Yes. Right? Notice they're different arrows, but what do? They both point to the same place. That's when they're equal. So what happens to my loop?
It stops.
Right? My loop ends. And now that my loop ends, I'm no longer in my loop. The iterator was not created in my loop, so it still exists. Right? Now I can run my algorithm, and I have enough arrows that even if I screw up the order, I'm normally okay. But first thing to do is to get rid of John, because the whole point was to remove the tail. Oh, look, see, my algorithm does it differently. So the first thing I do is I just say iterator's next node equals null. Right? You can do this in kind of whatever order you want. Right? Iterator stop, so is iterator set next node null. Right? Then delete tail, which deletes what tail is pointing to. And then tail equals what?
Iterator.
Iterator.
Uh-huh.
And then decrement the size. Does tail point to the last node in the list?
Mm-hmm.
Does the last node in the list point to null? Does iterator go away because the function ends?
Yeah.
Do we decrement the size?
Mm-hmm.
Hopefully.
You multiply it.
Right? We should be good. Yeah, multiply the size.
Just multiply it.
Oh. Does that make sense? Remember, when the list is empty, we don't do anything. When head equals tail, then the list is of size 1. And we just call remove what? Head. Right? This is my last condition, else. Two other simple algorithms I'm making you write today is to get the value of the head node and get the value of the tail node. Right? Remember, we can get the value of nodes by calling that accessor for contents. Right? And so this is basically saying, can you return head contents and can you return tail contents? Okay? The only problem is that when your list is empty, calling head contents will crash your program. Because head points to where when your list is empty?
No.
Null. If you ever use the arrow operator on a null pointer, it always crashes your program. Remember those segmentation faults you're getting now? You never used to get those, right? You get them all the time now. It's so lovely. Most of the time it's because you're dereferencing a null pointer. Right? And then just some simple error checks. So this is lab 19 that we're working on today?
19.
18?
19.
19. Okay, lab 19 requires a working lab what?
18 and 17.
18 and 17. Okay, you're going to copy all the files from 18 to 19. Right, your SL node, 2 files, SL list, 2 files. You're going to copy those over, right? And then the instructions will talk about what needs to change. But basically what? You're changing add head, remove head. You're changing both of those functions. You're changing clear, although that's a really easy change. You're adding 2 new functions, add tail, remove tail, and then you're adding 2 more functions, get head, get tail. But those 2 are really short. And the changing of the other 3 is actually really short. So we should be okay. All right. Remember these slides, right, are on Canvas, both in PDF form, which look really ugly with the arrows,
And then
and
PowerPoint.
PowerPoint form where you can actually go through the things. But probably more important than the visualization, although the visualization is nice, is remember the algorithms are in there, right? So, right, this is pseudocode, is it not? Right, so the pseudocode of how to do these things, right, is in this. Make sense? All right, midterm a week from today. Yay. The assignment's not due for 2 weeks, which means you still have 2 weeks before you have to start it.
Oh, just start it?
Actually, 2 weeks and 1 day behind that. No, you should start it now. Remember, you can write the whole node class right now, right? And it's not hard to do. It's probably easier than what your lab is to write the node class. Yes, because you're doing SL node where you only have links going one way. So your class is SL node, right? And your assignment, they're DL nodes, because they're W.
Oh,
So you have arrows pointing to next node, but you also have an arrow pointing to previous. So they both point both ways, right? Which for the node class is really easy to write. For the linked list class, it's pretty easy to write, but some of your algorithms need to be updated because they have to handle both arrows.
You can probably copy your stuff as a template.
And the nice thing is that in a double linked list, right, the lead and the tail node is actually efficient. Although a lot of times my students are too lazy and they just copy it over because it'll work if you start from the head. But if you think about it, if John had a pointer backwards, I wouldn't need an iterator here, right?
You just know where it's going.
Because I know where it is, right? So I can point tail to that and then delete the next node and send it to them. Right? So it actually becomes constant with a double. Good? I can stop now? That sound good? How'd we do? Pretty good, really, right? Remember, I was just go 10 minutes shorter than this, but I was 15 minutes late, so I saved us 5 minutes. Yeah. All right. Okay, so lab 19 is what you're working on today. I technically haven't graded lab 18 yet and lab 17 yet, so you have to do those to do 19 anyway, so you better get those done if you haven't done. Or you just decide, I don't want to do the linked list labs. That's only 4 labs, right?
It's only 200 points.
Check out, you know. Your grade will take a beating, but, you know. This is college, you can choose
To just not do it.
to not do it. You can choose not to go to class. Right? If you choose enough, then at some point they ask you not to come back, ever. But that's a cool one.
No, usually they just tell you can't come back to next year. Then
Right,
you
yeah.
Go back the next.
Right, and do it again. Yeah, it's community college, we take everybody.
Yeah. It's not like university where when they say they're not taking you back, they don't take you back.
Right, yeah, they're like, and we're done.
Unusual that education is like one of the more permanent things in the world. They're like, hey, you can't take that class for the sake of X amount of time. Applying it like, you just can't wear them anymore.
Right, exactly.
It's impossible.
You're done for. Doesn't matter if things change. You have to petition the one you want. I want to learn it again. I can take calculus again. I haven't done calculus in forever.
Oh.
You guys are like, what? Why am I in calculus if you don't ever use it? I don't have a good answer for you. That'll make you feel good.
The good answer is because the college needs the money.
Yeah, right? And hard science classes, we like to think that we're stuck up and so, right? If you can do calculus and you can do physics, then you're a real scientist. And, you know, pat on the back.
It's like easy mode. Community college is like easy mode.
Yeah. Now, if you go into like making like physics engines for games and that kind of stuff, guess what you're going to use? You're going to use calculus and physics a lot.
Not really, because almost all the engines are.
That's true. If you're going to make your own, like I said, not if you're going to.
Yeah, you're making your own game. You're just borrowing someone's engine.
Yeah, exactly. And you can. Right? Guess what those engines are written in? C++. Yeah. Bunch of pointers.
Not really C++, is it?
Yeah.
Everything's C#.
Yeah. Now you might use the game engine with C#, but the game engine itself is written in C++. Node.js, which is a big web framework for JavaScript, it's all C++ behind it. If you want something to be really efficient with memory and quick, guess what it's written in? C++. Then if you want regular people to be able to actually write stuff for your game and all that kind of stuff, then they open it up and say, okay, you can use other languages for it. But like the engine itself is C++. So there you go, you guys are doing the hard stuff. Congratulations. All right, I'm gonna start talking.
Trying to finish assignment 3 and 200 we can make sure to include or use in the
Well, this looks like something I changed in so this has no match software that to be write an overloaded operator for your to-do list. It's in the to-do list. We decided size to know, but I think size is an integer, so once you know it, it's and I think the list is not a string, right? It's not like a string with 2 lines. It's working in that one. Yeah. I'll still show up. Right, you gotta get this stuff, some foundation for next time. Yeah, so, yeah, appreciate the heads up. It's alright, if the head is small, really it's the same. Because whether or not it's small or not, you just point the new node to head. So temp is your new node, right? And then you're trying to get the context, right? So not star temp, because temp is a node. It'd be temp arrow set. And then it's a because when we want to change the node, we have to use
so your declaration point is the start. So then you have to use the name of that. Whatever that name is, it never needs to start. See what I'm saying, right? So you can just and when you name that like item pointer or something, that would not be the same. So if you don't need these, yeah, it take this down away.
Right.
The arrows.
And even if it wasn't pointed at all, that's fine with the next one.
Also,
So.
to do items is a type, right? If you don't look on the type, you're working on the actual item. So that says you're an action should be.
And the last step is.
So this was a little tricky. You need to. Oh, you're into this.
So the new head points to the old head.
No, yeah, usually. You delete 10.
So,
This is called the we're not deleting it. Yeah, what happened is
Yeah, so the other issue is, so the list is, it's a pointer to a list of pointers that point to items. So if you just the list, you delete all those lists of pointers, but the things that they point to still exist. So you need to, before you go through and basically each individual item, and you back to it. And last time I did it, don't cross that bridge until you do. Less than size.
Right? Sometimes it's just figuring out, oh, this is the syntax. And once you write it now, hopefully that syntax will help you out.
Now you're gonna, I guess we're just going to, just be one line.
It has no.
Space list. There's an arrow.
Yeah.
Oh, yeah. Or, wait. Actually, I'm sorry, take away the arrow. Yes, yeah, exactly. Here you go, perfect. So basically, now it's gonna think it's gonna take each individual item. So when that loop is done, you do a list, which will do all those pointers, and then you set list, so that should say this.
So, okay, so you say, so it had equal.
Oh.
Yeah. Type down.
Yeah.
Now, that's down, no.
Yes, okay, so, yeah. That's not that. That's gonna be.
Okay, cool, thank you.
Yeah. So that,
So, is it broken stuff?
that's good. Oh, you know, that.
Okay, gotcha. I don't know why. It's whatever user, email or username you want.
No, you have to look at it here. I try reconciling. I think it's fine. Maybe the other issue is we can. This is image based stuff. If you're creating a list of pointers, not just oh, that's the other thing. So you need to set all of them in null. So you need a for loop after that happens. After it's created, yeah. And the for loop basically goes through that. It sets like that. Just do sort of 25.
Set list, no?
Yeah, list, move from the list, and then assign it, yeah. No, that's, yeah. Okay. Yeah, perfect. That's all that we need to do. That's a full initial instance. Is this not a pointer? You left your reach? Yes. This one has a problem with
Which one says which one here?
Oh yeah, item doesn't have size.
Oh,
This is gonna be, yeah, items don't have size, list have size. A list has size.
yeah, I'm looking at this.
So yeah, no, you had the right idea, it just executed on you like that. So it's not that, it's bracket size. So it's item at location size, not, yeah. And either there, there is. There, so in array item at location size, that's what it's supposed to be. And then you can just set something to it. You're storing the passed-in item to that location. So we need a equals item. Basically. Can you increment your size anywhere? You increment your size.
That's on the exterior.
Good question. Why do it right after this part?
I remember why. I'm not going to just write, last year, I think the other one did expand the words.
Yeah, so I don't think you need this whole else and then the other item size. I don't think you need any of that. Yeah. It's good and the size increment. Okay, so
question on the question.
Well, I think I had an error with the last one. So
Okay.
Your issue is.
I have my int and my h as main node, but my int over
So
here.
size is unsigned,
Yeah, because it doesn't,
location.
when you're age, it
unsigned.
doesn't,
So-
it's just a significant. What do you mean major?
Okay, okay. Nice.
Yeah, and what you'll start seeing, is that people
Think of it this way, signed and unsigned, like all it's talking about is whether or not it has
This is just
negatives,
saying, what did it take?
right? So if it has a signed digit,
Here
it's
you
a signed
takes
one.
in an egg, and
Signed means it either is positive or negative. Unsigned
thank
means it
you.
can never be negative. If you go 1, 0, it doesn't go -1 unsigned, it goes back to the maximum, which is like 1 negative, or 2 or something. So I mean, it can never be negative, right? And I think the reason that's useful, the size of the list can never be negative, so you're gonna have a negative size of list, you can have a negative. See what I'm saying?
the same kind of check
So
here,
that's why
right?
they're important. Anytime you're like counting something, it can't be negative. Almost always for the, at least in our experience.
So you said it, that doesn't.
I don't think we've been catching it in a situation.
Oh, you said on there, so I can still, the updating of it. So that, does people know that's what you want to do deletion. Right, and then the key here is that after you move head, if head is now null, that's what you have to say. That's all you have to do. So you're really dealing with the head, but you're dealing with, okay, I removed the last node, let's update.
Do you not have your basic? You must not have your includes. Did you include the H in your CPP? There's your item H. Go to your CPP file. Go away. Oh,
This is on.
okay, you got it.
Yeah.
What are we making?
It seems that's not
Can we
a.
just, like declare an initialize pointer without giving it?
So, I mean, because in the H, the type's SL node star.
You have.
And that's its name.
Okay, so.
So in the private section, SL node star next node and content.
I'm not positive. I think this is gonna be.
Yeah, so we'd be on that, yeah.
So,
Yeah, which is funny because that's what you're writing as SL node.
That's exactly what I have.
Yeah, and then next underscore node underscore.
I'm having an issue accessing members from the SL_node.h because I'm trying to set the next node and it says that member doesn't exist in the SL list class.
Well, because it should be.
'Cause I'm
it
including-
only exists in the SL node.
Yeah, I'm including that up here.
Go to your SL list.h real quick. Scroll down. Scroll down, scroll down.
Does it also have to be in this file? Or do I have to
You
include?
said head was of type SL list star, but it's not. It's of SL node star. That's where it. That's where.
I see.
You're using that file.
SL node star is a type.
Yep. Because SL node is a type, and anytime you put a star in it, it's a pointer to that.
Okay, that should fix the problem.
Because you're writing a class called SL node, so that makes it a type.
I didn't know you could do that. I didn't know you could do that.
Yeah, you can create whatever types you want.
So the error is on, here on this line, saying that, from what I understand, it doesn't like that.
Yeah, what? You're saying item size equals item. I don't think those could be on both sides, right?
He was helping me out trying to get this to work.
Well, what is this? What is this? What are you doing?
This, using the pointer at location size.
Pointer at location size?
And that's what I'm understanding.
Okay, so you're adding a to-do item to your list, right? What is your list? Your list is a what?
Series of pointers.
Not series of pointers.
Sorry.
They're grouped in what though?
They're grouped in array.
Right, so that's the fundamental thing about an array.
Sorry, I
Right?
got my.
So when you use square brackets, you're dealing with an array, right? You're saying item square bracket size. Is item an array?
No, it's pointer.
Right, what's your array?
This list.
Okay, yeah, right.
So it should be,
So if you're gonna store stuff into your list array, then you should use list, not item.
so it's this item for the list, right?
Over here.
think it was a second. Nope. There must be.
Why is that the right way? Because list is your array.
Yeah.
So if you're gonna put square brackets on something, you're not gonna put on items, if items on the array, you're gonna put on list.
Alright.
List is the list, square brackets always go on.
Alright,
That's
thank
why
you.
that order is the right way.
Okay. So you need to go to metrics, get card,
And that's kind of the idea. I mean, that's the idea of that class is that you form a team and it's like, okay, yeah, I mean, we all know a little bit of programming. This one's really good at database. This one's really good at front end. This one's really good at back end. So, the two of you, I think, working on something. To get that paper into, I have the other places and I'll fill out that.
Other bars,
Oh, yeah.
So I'm voting after the game. That's right.
it's fine.
think it's because I'm not communications ready. A lot less than I
We're talking about public speaking is fun.
Especially for computer scientists.
Yes.
This chick gave her speech at a casino. She got only 5 points less than me. So now I'm just like, shit, why am I even trying? I might as well go to the bar and get my speech. Graded like that.
So I want you to create it, but then when you define it, it should just be open
Is
curly
it online only?
Yeah, no, it's an online public speaking class.
Yeah, see that?
You
That's us.
want to private up
No, dude, the one in person
That's what we meant by interface.
I tried it.
I just meant the names should be the names that you did, which I think are.
No, it's easy for you, that's
Yeah.
hard to find.
Yeah, that'll
I use public speaking.
And then I just
Yeah.
I did
Yeah, that's
street
fine.
for the Air Force, so
Yeah.
it's law enforcement, you have to learn to speak to the public.
Oh, yeah, I feel you, you got your
So-
training already.
It just makes it easy.
I just get mad, I'm like, I don't wanna do it.
So many people are like cringing, and I walk up there and I'm like, I practiced for 5 minutes, I got this.
Yeah, well, okay, so that, so this should be, then like, this should all be around. Right, because it's neither or, right? We've already removed the head, we don't want to do anything else.
Right.
So now you gotta yell, so that would be then remove the head, start with the tail, right?
Optimize on this. And then you gotta adjust it. Why you not? It's just because.
Luke, I don't know that already is one of the wow. That sounds like
Did you, are you using priority with damage for? No.
The function.
You can look through some mine. Okay, you're missing some stuff in content.
Well, Tuesday's the one that time. So you'll almost always crash, if something's wrong, you'll almost always crash it.
Oh, you run
That's what it is. It's right.
That's why I just kind of.
Why not too strange?
Yeah, but-
Yeah.
It's just
Yeah, I mean, it should be the same. The only difference is the priority is greater than, there's one priority, the priority swap values. So if it's true, and then swap values, J,
This is saying, so you created a new notification, and you're playing it backwards to the whole tail.
I don't believe you need the,
Probably why, which is probably
these
why.
priorities, because all those do is return.
The second one. So it should be.
Yeah, you know, I don't think you're gonna be able to use your swap values, at least not like this, because what you're swapping are points.
Because I never
Swap values
started.
does, it swaps integers.
Okay.
So, I mean, it's pretty simple, because that's all it does. And that's, so all you're doing is you're doing that and putting that in place of it, and then making these work with what you're working
I
with.
don't think I left that. So I got home.
I basically like, so I had created an item block called to start, and I put J into plus that J. And then put in the J, the next spot, or, and this is of course if this passes, right, which you have. And then J plus 1 equals item, which is the new item that you're creating.
They don't.
You split swap it true, that's part of it.
Because I'm not working around and stuff all the time.
But,
I think I'm using that
If you
for
have the
one
option.
more.
Yeah, so you store one and random up that.
Sit at home and then that's such a
That's okay. The only difference is that board, it basically tells it that it's done, and it stops it, that's for.
Yeah.
because what I get for sure, and it covers the same thing as
Yeah,
all
but
three
if
of
there's
us.
a lot of competition.
If there's 0 nodes and there's 1 node, that's the same, that's for your insert tail.
Insert tail.
If it's 0 nodes and if it's 1 node, both of those situations, we just call your insert tail.
No, when it's 0 nodes. When it's empty, you call insert head, so you'll add 1.
Right.
Once you have 1, then it's insert tail in the algorithm.
Right, so the new algorithm is effectively just updating
You
your
go,
tail form.
no, I have no clue what the information is. Doesn't mean I'm okay if you can't take it. Well, unless you can't project the experience. Writing code at home, or just making projects, you know, is the way that is, we're just gonna do this based on. So you can submit that, they'll look at that.
Not what they said. Yeah.
Good luck.
It's not super.
Alright, I changed all of my types back to SL node star,
Okay.
and now it's telling me it has an undefined reference to some of this stuff. Like this doesn't name a type, and then head is not declared in the scope, even though I defined it here in the H file.
Right. Yeah. Okay.
I'm wondering in the H file if I have to put this, and then when I put
You
it,
do. You didn't do that.
if I did that, a bunch of other errors pop up.
So you do that.
And it's telling me like this is not defined or not declared.
Okay. Let's see.
Yeah, just this one. Yeah, just that one.
Oh, so you'll notice that these header guards say Peters Labs 18, right?
Yeah.
But your list header guard also say Peters Lab 18.
Oh, okay. Yeah, let me just change that to 19. Right.
Because it can't be the same, because then it says, oh, if it's not defined, define it. Well, it defines one of them, but not the other one.
Yeah.
Like, literally, your list doesn't exist. There you go.
Now it's telling me that next node is not declared.
Well, that's just because
I'm trying to convert. Yeah.
It should just be new SL node. I don't think star. And that might be backwards, anyways.
Because that's
Int is a contents, right?
Yeah.
Really, what you're trying to say is head, which is of type SL node star,
Yeah.
equals a new SL node, right?
Mm-hmm.
And then we have a constructor for SL node that allows me to pass it an int.
Oh.
You wrote that, so then just use it.
Okay. So this would just now point to those whatever that's pointing.
You basically said, right? The right side of this said, create me a new SL node, right? That has an arrow which defaults to null.
Yeah.
Right. You passed in content, so it starts with some content.
Yeah.
And then you basically say.
And then head points to that.
Head points to that.
Yep. All right. Cool. My thing, man. Who the heck did that? Thank you, Luke.
Now.
Yes.
Add my area with the next node.
And now you need to set.
And then you have to stay the one.
So we're just pretty much doing the same thing.
It's
swap values.
Wow.
You're doing exactly this.
So wow, and all you're doing in that one is
You store value 2 and value 1.
So it's
value 1.
you loop, and then one's down to the after. So it talks about each iteration, all you read would be iterated out. Each iteration, if you wanted to do this.
Oh, you do that all after?
And if you don't have anything to show for it, then we're gonna bump to the side. If you want to stop for you
Here, all you do is move iterated down. Because if you don't, then it's never gonna move, right? So iterators next time will never equal. How do I move the iterator? How do I move the iterator down?
Initially, you just revoke the floor.
So basically, you don't really need those. If you want to make optimize, the only difference is you create that. Yeah.
No, but I'm just trying to show you, so it's the same thing there, right? So I'm gonna start iterating this after. And we have a loop. The condition is slightly different, but still a loop, right?
Right.
this is just outputting, which you don't need to do, right?
So we're
This is
past
just
outputting. And then go back to your bubble sort.
Oh,
Now, after that, the iterator is now
I would just start there and copy it right out like that.
to the last, second last node. Last node,
It's gonna go right after this last line. So right after that. And I just need to make sure that you're opening the close bracket.
Iterator points to the last node, the last node.
I think you're gonna have one to
So, point that node, that iterator points to, oh, no.
Yeah, you're gonna have way to lead and I think it's. So that's the very end. Check those other two. You right about that? Yeah, you're good. So that's good. That's the advanced one.
This is not pointing the next node. No.
Unsigned into,
You want to set iterators next node.
it's supposed to.
Where at?
It says on to-do list without age, like, that's. It's supposed to be private, right?
Yeah, you have it private.
Not liking it.
Yeah, I'm trying to figure out where it's trying to be. Oh, it's called right here. Go to your list CPP. There's at 93. Do the prints. Replace the underscore again. That's gonna be your accessors.
Okay.
Yeah, correct.
Wow, the iterators next node.
That's right.
So then, this is saying, this is actually going on right through this, like, point that node.
Oh, arrow, use arrow operator.
What's wrong? What's wrong?
The same?
So how do I
Use arrow? No, it doesn't.
Well, yeah. That's why.
Oh, it's T list.
Yeah. No, because I can usually go get this or this is something here. A piece of code. But this.
You're missing a
bracket,
semicolon.
Oh,
Yeah, it's not the semicolon.
So, you put in working inside of it.
this needs to be.
No. You just want people to shit on this.
After you say.
So, usually they're missing numbers. But they're just not.
It's like the one time where you're thinking about something else. You're just like, yeah, can I hit delete or something?
Content, James.
Yeah. You're a lot
There's another one. There are two things is they do braces.
I think mine is also.
Deletion was help. And that's just not in the correct order. And then you're like, I wasn't going to this needs to get shipped, this needs to be shipped.
So I think this supposed to be T dot list.
Because that's like everyone's solution.
Then,
You just need to further. They
Yeah,
don't
okay.
you plug it back to their code to see.
This underscore, so now, arrow operator size.
So you see here is that,
I think that's how that's supposed to go.
this one you have to use that next node, because you were dealing with stuff inside the node. This one you use the assignment operator, because these gray things are not nodes.
Yeah.
So that's the difference of when you have to use the indicator versus.
Oh, sorry, okay, so this is just gonna be,
Yeah.
It's confusing.
Yeah, that's that one. No.
The iterator set next node to null, delete tail, great.
And then,
okay, I'm not sure, because
You already done it,
that,
though.
what you had is actually what I had. It's just T dot size. That's what I had.
That's the.
and
No,
that's a lot.
I didn't use that, I used that. It's the size.
Yeah, okay, thank you.
It's
Yeah. See you later.
What you got? So to move it, you have to say, yeah. You have to say head equals. Okay, so one way we have that. Oh, this is good. But then we say head. So the head pointer points to, basically like if you look at this picture, you're saying head equals heads next node. So now those two arrows. And if there are more nodes, right?
This one is I.
Backwards, same size of location T, but, or well, not even location, size of to-do list T. So T is a type of to-do list, so yeah, the to-do list T.
I mean, clearly it'll be the same.
So I'm almost thinking that needs to be an arrow.
Assuming that everything got moved. Assuming that everything got set up correctly, you know what I mean?
No, I'm not sure, man. Yeah, you might have. I'm not sure what's up with my phone. Do you have the friend part on your page file?
Started at no.
Yeah. Oh. That's missing your T. Space ampersand T. That might be your problem. Yeah, you're getting different ones now, but that was it. We got a whole slew of other ones. Oh, no, it's good. Oh, no, that's what was it. Yeah. That's the
last thing you do is delete. Whatever temp was pointing to is gone.
very likely to do that inside an actual.
Then,
That's usually, that's like a class type. So whatever.
This is gone. So it's probably working still, because it's not, you know, it's still there. But that's actually. That kind of.
I was basically trying, I think I had a right point.
Head. And then you say, well, head doesn't equal null, and then.
I thought I was calling it file function.
It's very confusing because.
Then I would go back and fix the other one. Then it crashed for you, but it could crash for me. Does that make sense? Because my memory might be a little bit different than your memory, and it might be.
Then we started to see that again.
But I do believe there's one in your item, and there's also one in your. So there is two.
Yeah. See, I mean, from what I understood, that's where it comes from, file, here, into item.cpp. So that's why.
Item is, but not in list. The list has its own two files. So that's why it's weird. But it's just the basic difference. I think the item just does the scrub, and your two files just called scrub or something. And then the list one to, it builds the two files, that should be the string. But the other one, the string is just changing, it's basically like a scrub.
I thought you did the string in there.
No, that outputs the string. It's sort of, I did build it in the
I guess it would.
I was going to do item.
I'm wondering.
Change the string between all of these items.
I think two file only pulls one items.
I'll be there in a sec.
And the operator does the whole list. The else part of the next thing, which is basically saying like the opposite of the if statement's true. So if you have like, if head equals null, is equivalent to null, the else part will basically be if head is not.
Yeah, so you don't have to say all it's just, yeah.
Otherwise, that whatever's after that initial if statement will always run.
Yeah. Well, the way you can cheat if you really don't like to be inside of like an if else. You could say if head equals null, do this. You just say return.
That is what I actually did. I did return from them. Oh, but I don't need the else.
Who wants to end it like that?
I always feel like they look so sloppy. I don't know why. I really not, but it's just weird. I always feel like they can be avoided. Is there a scenario you need an else?
I mean, it's not. It's harder to debug if you have a bunch of returns, like if this return, if this return, if this case benefits, if this else.
That way you can put like a C out or something.
Yeah, and just
Well, and I just feel like it's easier to read.
So then you get confused, like, is this part of that? Is it not? Yeah. Here, click this curly, yeah, that's everything that's part of this. And then sometimes people will miss that return, so they'll think that they should have it, even though they don't get that.
Oh, I see.
That's easier when you're writing code with another person.
Yeah, you have different styles, then it gets.
So yeah, trying to think of it as
my boss.
think of it like a variable name, right? That's not a variable name. That's
Started
a
going and then not
So
commenting stuff.
whatever their variable type.
So then I'm trying to go back,
Probably
fix this,
Right.
and it's not working like that. What you do here, what is this?
I don't understand.
Yeah. Yeah, I would person that to listen. Yeah, pretty sure.
Because like,
That doesn't have the underscore. Are you making it? Oh, yeah. It still doesn't have the underscore.
That's weird.
So I was running into this problem. Just press anywhere, press it. Yeah, press it. You erase it? Now make. Give a second. See, now it added it in. See, that's fine. Now this is wrong. That's what it's name. Maybe it's that. I don't think that's the case.
Yeah, I think that is. I'm trying that.
Let's switch it back to normal.
Did you get it? I gave you some time. Did it work?
Well,
You're missing parens on next to
Is
me.
all supposed to be
Yeah.
two files?
I'm wondering if
Oh.
this
I
is
guess I'm worried about
also messed up and that's
my
the,
insert field,
file.
is this? I'm just-
So that's not what your two files should do, as long as you're on your list, right? What you're making it do is just, you're trying to call the original two files and you're on the new node. It's not what it does. Your two file should basically do a for loop that builds
Oh.
strings.
So you're creating a new node and you're saying you're pointing it to the current tail. But the new node is the new
Which is the
tail.
entire list.
Oh.
Which you're pointing back. I'll let you do that.
So this side needs to go over here.
Then if you do that and your operator outputs a numbered
Okay,
list.
thank you.
So yeah, this arrow off, this right here, overload, actually formats the
No,
list.
just move, just swap tail and new tail. Leave all the other structures the same.
Operates on the list. And formats it, so it's good. But so to-do list should actually be a for loop with an SS string. And it's basically just taking, it's running two files in each element.
okay.
So that's the two files in your item H.
Item,
Well, this one is.
because this is what I had on my.
Yeah, so that's what that one does, it scrubs, right? It basically translates the names or whatever. That's what it's supposed to do.
And it's something that not, wrong, I was just wondering, these what these things, okay.
Because you're dealing with a single, in this scenario, it probably won't matter because what you're putting them into is a string string, and that has a lot of type conversions built into it. So, but if you were putting it like straight into a string, yeah, it would matter. It doesn't have a lot of
Well,
right.
the description,
So that you're in, you're in item, you need to be in list.
yeah, I know, I'm just figuring that this might be time.
It might be, but I would fix this one first. Right now it's saying. That's super weird. It's telling you to use an arrow, when in fact you used an arrow and it shows it right there. But basically, oh, that's gonna be brackets. You're storing that, and you need to be storing that into something inside SS, basically. Yeah. I want everything that's stored in SS. And you return.
I have no idea why this computer is being stupid. I am using an arrow operator.
Still working on 7.3.
Yeah, there's centralized to error messages. I think my computer might be brain damage. Or motherboard damage, whatever it's called. Because it's saying that I'm not using an error operator when I am.
Are you using it in the correct way?
I think so.
Which is pointer type 2 letter star, maybe you meant to use point.
Request from member two file is to restart this list underscore, which is a pointer term. That should work.
Yeah,
This underscore is your object, right?
yeah,
And you're trying to dereference it to require a string from that object, like what's in the object, like the items in it. Is that what you're doing?
what I understand from
Because
the,
I think that's what two files doing, is it's taking all of the items in the object and putting them into a string.
yeah, that's what I understood. Here, at least from what I understand, they're calling the two
And
file function from
Is
here.
two file, is that right?
It's a function.
Because you're accessing it like it's an array. Did you say two file and then bracket I don't think you did that.
Should be function.
Yeah, but what, hey, is that supposed to be on orderly?
And that's what I need for I'm looking at.
Or,
Oh, yeah, you choose your file.
yeah, but is it two file like bracket I, because it's not an array? Because he did that and it was freaking out.
To-do list, I need to be right now.
Yeah, the list is an object, that's an array, it's a dynamic array.
Yeah,
And then, okay, there we go, because now you're accessing every
each
item.
individual item.
Yeah, each item.
And then this, I believe this takes that list and.
Yeah,
it's a-
That's the one, boys.
How would you ever remove head function? Because I'm having a problem with, using next node. Head underscore equals head, oh. So you have to say head underscore equals head underscore next node. Because I just did head underscore next node and it was like,
Oh, yeah. It doesn't know which next node you want, because you have, each node has.
yeah, so I made a pointer temp that basically is assigned to head underscore, and then I have to say head underscore equals head underscore next node, and then now I know where the next node is.
And then you just straight up delete temp, and then temp gets deleted, you don't have to set the null or anything.
Well, yeah, I don't even think you need to delete temp because it's a function.
So you do, because it points to head, right? It points to the old node that you're
Yeah.
gonna get rid of. So it's a dynamic chunk of memory. So if you don't delete temp, that dynamic chunk of memory stays there. Temp gets deleted, which is a pointer to it. So it's a memory leak. So you gotta delete the memory leak.
Okay.
No, that one.
Okay, so.
Once I had to take something.
One of the two file function.
Your descriptions.
Look at that, like, you already called the function, right?
Yeah, but the thing is, it's not gonna know,
Right?
those are not those good, right? You need to be like,
Oh, just one.
yeah, list, or well,
And then,
yeah, it's gonna be list. Let's see, that's your two files in your item. Oh, wait, I'm sorry, that's the wrong one, that's your scrubber. Sorry, just one second.
That's the last.
Next.
You have no function called set new node.
So, two files. Right, and then stream, and then yeah, so it's scrub description. Right?
Oh shit.
That's the only thing you're running the scrub on. You could have done it that way, but you would have to have stored that into a variable, and then you would put that variable into the SS. But you don't need to. You might as well just move the whole thing.
Create
Straight
a
into
node.
add an extra variable.
Emails.
So that's gonna be scrub. Yeah, scrub.
So we said that.
I always think that when you're actually define like, say, priority underscore equals a priority.
The first two lines.
Just call it a priority.
Now,
Without the underscore, it's user input, right? So if you're in there, it's because it's receiving input from someone usually.
Because we haven't added
You
it.
get a compile.
Yeah, fine.
If I created a node, but
Yeah,
if the list was empty, even though I created a node, the head's just was empty. So if the head is null,
then the tail should point to that. Because that new node is just the first.
That's right, yeah, it's fine, it does that every time. It's because we're
And
happy.
if you don't introduce tail, then all your tail functions don't work.
So you aren't getting a segment fault summary, you are getting all the tests at the same time. You got a segment fault summary.
Oh, number test 53.
So I don't know if the tail has some of the same.
But you gotta, it's likely gonna be one of those error operators or something. But it's
Tail. Right,
It's not showing like all that test now.
if you create a new node and you
because of a segment fault. Right, that means that it crashed. It wasn't able to complete it.
I had this
So
problem.
if head is null, maybe.
Those are pretty much the hardest things to diagnose. You don't,
Otherwise, we create.
he doesn't have to look at it because he's very firm, because he probably spotted it like that. But when I would have that issue at home and stuff, I would just spend hours looking back
But
and
you delete it, you know, why do
then it turns out it was headed, mine was in a different phone.
It is, but the tail node has some null. You call it new.
Or,
Blah,
blah, blah,
the same
blah,
thing.
blah, blah, blah.
Yeah.
It's like a
And then
zero
that's
sum.
not running.
Yeah, it's not good.
It's
So how do we? So tail, the next node to the new node, right, because it says point the tail node to the new node, and then it says point tail. You say tail.
I gotta work it. I feel like
So it says point the tail node to the new node, that's your line 38.
It's a many and a new tail.
And then your double increment size, right? Because insert has been increment size. So this size also should be less than 2. Yeah, well, because otherwise, think about it, it calls insert head, possibly, with increment size, and then it jumps down there and increment size. So then, it could be. A long time ago, right? Yeah. So almost 13. Not 22. You could probably find 13. That is long. If they're equal, if they're equal, that's what you this algorithm does not here. Because if they both point to the same place, then they're on one thing and they're one. Oh, yeah. So try that and see what you get.
Oh, you got my program compile.
There we go. That's step 1.
Kind of segmentation off. And I'm not, yeah. I think that's to-do list, but I'm gonna add this my constructor right here, but I'm not really sure, where the fault is.
Add item, if the capacity equals time. This is basically it's full. It's full, increase the capacity. Well, it's fine, you still have the curly brace, but you weren't actually, you know, only actually item when it's full, but it's not full. So if it's full, do that, otherwise you always add the new item, the new size. Which means that add item, which is your first failed test. So you have some default. Failed test first. Right?
Yeah.
So it's not about the segfault first, it's about that.
And that's one that I edited, and forgot to move
So
the.
now you pass. Alright, now you pass it. Pass it. And then the question is about this. So I always just try to match up, like here, star, to-do list constructor, star, to-do list constructor, right? Star, to-do list, one item, star, right? With one item.
So it's,
First
get
test,
item.
well, yeah, first was add item, second one was get capacity, right? Third one is what?
2 file.
Right, but not really the 2 files, the 2 files running on the item, it's really the stop button. So your get item might have a phone, so it's a button.
Okay.
So here's your get item. So my guess is that something with this is wrong, but my guess is that you're probably returning null. You'll notice that in my test, I'm not expecting null, I'm expecting something that I can put 2 file on. So my guess is that in your thing, this if statement is probably wrong. So instead of it returning this, it's returning null. So look at your logic there and see what you can. It could just be one symbol, it could be off by one. You should be done with it.
I tried to do that. I just gotta figure out how to get the pointer.
Well, head is the pointer, right? Of type SL node star. Tail is the pointer of type SL node star. Both of those functions are returning one. No, that's the return type, right there, line 74.
Oh, well, it wants to return.
Yeah, so you're not returning an integer. How are you returning an integer? Remember, what is the pointer pointing to?
The contents or the,
No.
like a number.
It's pointing to something like that, right?
Yeah.
Just replace it, right? There's head, it's pointing to a node. So it's pointing to a node. You're trying to point to a node. I don't want the pointer to the node. I want the thing inside the node. How do I get the thing inside it? How do I get the private data inside any object?
So just looking at.
Private data.
Because inside the private data, you have a variable called contents underscore, right? But you don't have access to it, it's private. So how do I get to private data of an object? No friends, can't call them friends with this, sorry. Remember, you have 4 functions. Right? Those functions are the way that we deal with the private data of my object. So which functions are these?
Well, it's not set and it's not net.
Yeah, no, I think that's right. And it's.
Okay. Alright.
Neither the set functions, and it's not the next node function. What are the functions? It's not the successor for your integer.
And so do I just have to, can I just say return and then contents and then inside parentheses, can I just say? No?
Those are functions
So
on
you need to
object.
make sure that your
Head
choice
is
is
a
not
pointer.
only smaller than size, but also bigger than
You have to start with head, because it's the pointer to the object. I want to call member functions on a pointer, I don't use the dot operator, I use the
So
what?
he's passing in. So it's just.
You can do it.
So that ensures.
What does this
that
do?
it's right.
Here's your 2 strings. What is iterator arrow contents? What does that do? It's the integer value, right, of what the iterator is pointing to.
Oh,
So you've done it. You just gotta remember.
okay. I thought that was a string, but I don't.
You added it to a string. Doesn't have to be a string.
Yeah.
My pictures, right, so in my slides is a string. In the lab.
That was my choice instead of creation here, but yeah. Everything else is not the same. Oh. Less than it equals. Or what? Okay. That's what I have, but I'm not realizing it.
Good, how are you?
Everyone's got farther.
And then, oh, but, well, hey, I mean, you're getting there, man. I've seen it, I'm sure,
Sure, I'm not in a rush, right?
We're fine, we'll make it, yeah, so don't worry about the class now. It'll happen.
Okay, they said like, they told me that I had to.